Hello students, let's calculate entropy changes. Let's see entropy changes in exothermic reactions and endothermic reactions. You must know that an exothermic reaction is a reaction in which heat is given out, whereas in endothermic reaction the heat is taken in. Students, in exothermic reaction the energy is transferred from the system to the surroundings, whereas on the other hand in the endothermic reaction the energy is transferred from the surroundings to the system. Students, these surroundings are so large that when energy exchange takes place, there is such a small change in temperature or pressure that we can ignore these. For exothermic reaction, there is an increase in entropy and increase in probability of chemical change occurring spontaneously. For exothermic reaction, what happens is there is an increase in the number of ways arranging the energy. This is because the energy goes into rotation and translation of molecules in the surroundings. So there is an increase in entropy and there is an increase in the probability of chemical change occurring spontaneously. On the other hand, for endothermic reactions, the energy absorbed from the surrounding decreases the number of ways of arranging the energy. So there is likelihood to decrease in entropy and decreased probability of the chemical change occurring spontaneously. Okay, so let's see the total entropy change. The total entropy change is symbolized by this delta S with this sign. It is for standard entropy change. Students, we can use these values to predict whether a chemical reaction will occur spontaneously or not. When a chemical reaction takes place, there is no change in entropy because the reactants and products have different entropy values. Okay, so the symbol is this, and we calculate it like delta S total equals to delta S system plus delta S surrounding. So if this total value is increased, that is the entropy is increased and it is positive, the reaction is spontaneous. But if this S total, delta S total, it is decreased or it is negative in the value, the reaction is not likely to occur.